welcome to the third annual BTR Summit. My name is Sean Buckley, Editor-in-Chief of Broadband Technology Report, and we're very excited to join us here today. I want to first give a big thanks to all of our sponsors and partners who have made this event possible. This includes our gold sponsors, AFL and Sienna, our silver sponsors, Calix, Harmonic, Precision Optical Technologies, Technetics, and Viavi Solutions. The BTR Summit is brought to you in collaboration with SCTE, a subsidiary of Cable Labs. SCTE is offering recertification unit for attending this event. To receive SCTE recertification unit, you must fill out the SCTE recertification form and submit to the SCTE directly. You can find a link in the form within the recertification tab in the webinar player on the BTR Summit event site. More information about receiving an SCTE recertification unit can be found on the BTR Summit event site. The BTR Summit will also provide you with a certificate of attendance for viewing a session in its entirety. Let's get started with our first session, New PON Architecture Models. Now, before we get started, just a bit of housekeeping. To begin, let me explain how you can participate in today's session. First off, if you have any technical difficulties during today's event, please put your question in the questions window, and our technical experts will help you out. We recommend disabling any pop-up blocking software or extensions in your browser, as these can cause issues with the webinar player. Additionally, we welcome your questions during today's event in this session. We will answer any questions as possible during the Q&A session that will follow the session, but please feel free to send in your questions at any time. To do so, simply type your questions into the Ask a Question window on the side of your screen and hit the Submit button. Also, please be aware that today's event is being recorded, and you'll be notified by email when the archive is available. Lastly, at the end of each session, there is a screen that will pop up asking you to fill out a quick survey. Please make sure to take this quick survey, which will help provide guidance on future content we continue to provide in this format. And with that, now let me introduce you to our distinguished panel of presenters. We have Richard Ramos, Vice President of Access Network Solutions and Strategies for Harmonic, Mike Emmendorfer, VP of Technology at Calix, and Kevin Knoll, Principal Architect at Cable Labs. You can learn more about our speakers for this session by clicking on the Speakers tab with the webinar play. So let's dive right in. What I would like everyone to do here is to kick us off by talking a little bit about how you fit into the ecosystem of PON. And I'm gonna start with Mike, who wants to show a couple slides. Just talking about setting the stage for the discussion. Mike, I'm gonna hand it off to you, and then we'll go to Richard and Kevin after.
Okay, Sean, thank you, and good morning, Richard and Kevin. Okay, what we have going on in the industry is Cable Labs has formed a couple of working groups to look at the acceleration of deploying ITUT-based PON technology. One of the things that they have asked the vendor community is to look at ways of leveraging the DOCSIS back office with the integration of ITUT-based PON technology. And in doing so, they want to make sure that residential services can be essentially just like DOCSIS, as well as business services would be deployed in a very similar manner than DOCSIS does. So the other thing that they have been looking at is where to perform some of the traffic management features. And those traffic management features are essentially the function that enables an operator to offer various services to their subscribers, high-speed data, voice services, as well as video services. And through traffic management, you can control how much bandwidth each application or each service gets, both downstream and upstream, as well as overall quality of service. The other area is what functions should be on the OLT system, and that's where, where does an aggregation router fit? Next up is going to be looking at the couple of different architectures here for the integration with the back office using ITUT-based PON technology. So this is an approach that the working group is currently focused on. It's leveraging the MSO back office systems, and those are going to include a wide variety of functions: lawful intercept, provisioning, monitoring, and IPDR, or the accounting function. And if we also wanted to introduce something a little outside the MSO back office, we could use some performance management collector using IPFix. But all of those orange lines here coming out of the DOCSIS back office then are all of the standardized interfaces that have been around for nearly 25 years, starting with DOCSIS and then with the PON technology that Cable Labs defined with DPoE and then DPoG. And then what we're looking at really is having this DOCSIS PON abstraction layer, a DPA, and then that will interface with the DOCSIS back office functions and then provide a translation or abstraction layer to the OLT that would have subscriber traffic management. Think B&G type functions if you're in the telco-oriented operator. But OLT plus subscriber traffic management essentially mimics the exact functions of a CMTS. As we look at from the OLT going over to a multi-vendor ONTs from various sources, we're looking at using OMCI defined in the ITU, but perhaps a more cable-specific grouping of those standardized OMCI management entities, and perhaps coming up with an open cable OMCI definition that would define then how cable will instantiate OMCI for their operators. And by doing so, we can have multi-vendor interoperability between an OLT system and ONTs. So, but cable and its members aren't really wanting to stop there. Some are looking at maybe leveraging some of the DOCSIS back office interfaces. In this example, you can see that lawful intercept and even IPDR is still leveraged, but then there would be a new provisioning interface as well as a new monitoring interface. Both of these architectures have already been deployed. Both of these are functioning. Both of these are completely enabled. It's just if a customer wants to have a complete back office or some level of another back office system for provisioning or monitoring functions. So the migration, though, that we could look at is what if we, over time, then migrated over to more of a broadband forum-based back office system with a network orchestration layer and then a service orchestration layer. And that's what this is showing. And what this basically shows is that an operator could deploy an OLT as well as ONTs, start with DOCSIS back office, migrate to some DOCSIS back office, and then even migrate over to maybe a full BBF style architecture without changing the OLTs and ONTs. So that's one of the big areas that the cable industry is looking at. The next area that we're looking at more deeply here is that area of traffic management. So if we look at where cable is today with the remote PHY architecture, you have the traffic management function in a virtualized form. And that's possible really because the MAC is in a virtual form. If they would have kept the MAC together like a remote MAC PHY architecture, then that traffic management function could have moved down to the RMD. But in this particular example, we're showing what the industry is looking at, a remote PHY architecture. And essentially, with having the MAC up there, you had to do the traffic management, in the cloud. So if you look at what legacy telco did, this could also have been a DSL illustration, but I used basically the first generation of telcos doing PON technology. They basically had traffic management sitting in a B&G, okay? And then an OLT could have been a DSLAM, but I'm just showing an OLT in this case, does have the PHY and MAC functions, but all of the subscriber traffic management happens here. So some of the telcos started moving to kind of a split model where some of the traffic management was in the OLT and then some was in the B&G. But if you look at where the industry has been going, it is looking at and what cable did. So this architecture places all the subscriber traffic management, the MAC and the PHY, because they're all together on and all on an ASIC. This architecture places all the traffic management functions, all of those service handling functions close to the customer and on an ASIC. And if we look at what the cable industry has done with traffic management, well, 25 years ago, that's how the CMTS was architected. And if you look at cable PON technology since 2010, that's how it was architected. If you look at what Verizon announced in 2018 in Japan, they announced that they were moving to an architecture that combined the traffic management and OLT functions. So many of the telcos are moving to this concept where an OLT is also performing some of the B&G functions. And then finally, if you look at the broadband forum, what it's been taking on with the disaggregation of the B&G in the 459 spec, with specifically the B&G user plane function, that could be pushed out closer to the customer and in fact on an OLT if desired. So what this shows then is a migration path, essentially what cable started with 25 years ago. And if you look at it, as we go from 10 gig, maybe even to 25 gig PON or even 50 gig PON, do we want to have all that traffic running through an x86 processor in the cloud somewhere? Or can we just handle all of it in an ASIC that's already exists? So that's really the big discussions. The third slide that Sean wanted me to talk about in setting up these topics is the area of brownfield deployment. So if we look at brownfield, the cable operators want to have a flexible architecture. Some operators in brownfield are looking at facility-based OLTs, cabinet OLTs, or node OLTs. And then for the operators that are looking at deploying PON in brownfield, they have decided that they're not doing and not going to deploy PON the same way they do HFC. If they did that, they would have far more devices. Why? Because the PON serving area distances are larger than an RPD distance. The remote OLT serving area is larger in terms of how many ports, a particular node, for example. If we look at things by service group, an RPD might have 1 or 2 service groups. A remote OLT can have 8 service groups, each with 10 gig. So that's 80 gigs of capacity for a particular area. So that's why if you look at deploying PON like HFC, it could increase the number of locations that have active equipment in the outside plant by perhaps 4 or 16 times. So designing fiber in brownfield, MSOs are looking at what's the end game so they can have as few OLT locations as possible. The other point here is about MSO brownfield overbuilds. They're meticulous to plan. One of the things that the operators are looking at is what happened during the last major rebuild, not upgrade, but rebuild. And that's where MSOs started putting fiber in the late 90s and 2000s to perhaps 6 to 12 fibers per node location. That node location could have 2,000, 1,000, or 500 homes passed. And if you place an OLT at that location or even further up, you could have then and utilize some of the densities that are found in remote OLTs today, which are like 8 ports. You could have large aggregation points if you use a remote OLT architecture, or even more massive aggregation if you use a cabinet. So that's why all of these operators are looking at not deploying PON in brownfield the same way they deployed HFC. They're 2 totally different architectures and technologies that can change the overall architecture. And then finally, the last point here is service providers of all types are looking at using cabinets to eliminate facilities. So I hope that sets the stage, Sean, and I hope that's what you were looking for.
Yeah, no, that's great. Thank you, Mike. Some really great insights that I'll certainly come back to revisit as we go through here. Next up, I'd like to ask Richard. Maybe you could talk a little bit about your point of view and what Harmonic brings to the table. Kind of go from there. Yeah, I think you're on mute, Richard.
Sorry about that, guys. Yeah, Mike's points and Harmonic's to mine overlap quite a bit. we also believe that a flexible architecture is required, right? Because cable operators are building Greenfield and Brownfield, and it's not the same solution in both cases. You're not going to put a 16-slot chassis in every node location, right? But on the other hand, Mike referred to it as massive locations in a cabinet or whatnot, maybe you would put that. The other thing too is that we're seeing is PON by the telcos have been deployed early days, and they went after the highest density areas, right? Because that's how you make the most money. I've been in this business more years than I care to admit to anybody in public, but as you gain this experience, some of that turns into wisdom, and a lot of that wisdom revolves around how do my customers turn what I build into a revenue, right? So you want to give them choices to be able to put efficient, cost-effective solutions in the field. And in some cases, it is just like Mike described. You put 4 or 8 ports out in the field, or maybe even 1 port out in the field, and you convert customers where you need to. The other thing that Mike didn't mention, though, in the slides were we believe that ONU interop is critical. There's been a lot of work done by the Broadband Forum, and I know Mike's aware of this. I just wasn't sure if I saw it in the slides. But we do a lot of work to be able to integrate anyone's ONUs into our platform. And what we found is that regardless of whether or not you've passed 247 or you're certified there, that every OLT and every ONU vendor have slight differences in how they integrate ONUs into their service packages. And it takes time to do. And that's one of the things I'm hoping that, Kevin and Cable Labs will help come to some suggestions for, and how do we tackle that. And then I think lastly, I just want to mention that for the architecture that Mike was touching on, where they essentially put an OLT application, or whatever that is, where the nodes are. We've done some studies with construction design houses, and we've had them do a design over from scratch. Take a design they've given to a customer and redo that design based upon a remote OLT architecture in the field, where you're putting smaller OLTs closer to the customers. And the cost savings are dramatic. And going back to what I've learned over the years, how do I help my customers make money? That's important.
Kevin, over to you. I'd love to hear your perspective from
Cable
Labs.
Yeah, so I think Mike did quite a bit to introduce what Cable Labs is already doing. Cable Labs is integral to the cable industry as a consortium of our members, and we are engaged with Broadband Forum. We're engaged with ITU, IEEE, all the standards bodies, as well as the MSAs that are involved here. Like Mike and Richard mentioned, we do have the FTTB working group, where we're working on OMCI as an interoperability concern. Again, trying to leverage as much as we can from what's already been done with the Broadband Forum and the 247 certification program, recognizing that that's a strong program, but adoption has been weak in our view. So that's a big thing for us. The other part, as Mike mentioned, is the DOCSIS layer. So trying to give examples of how the ITU world PON can be integrated into the DOCSIS backend, which is important to our cable operators. We're also seeing a lot of our members that are not adopting DOCSIS for the PON backend, and so that's important for us to recognize as well. And so we're working on that with them. I would want to bring up another, I think, important point in all of this discussion. We can talk about PON architecture from the network side. We can talk about BNG being virtualized or not being virtualized. We can talk about remote OLT. And I think this gets into the crux of it, the remote OLT versus centralized OLTs versus cabinets versus strand mount. In the end, we're really talking about bucket trucks. I hosted a panel a few weeks ago, and one of the panelists brought this up, and I thought it was a really good point, so I'm reusing it. Everything that we do in architecture, the most expensive part of this is the outside plant, how we maintain that, how we operate it. And it can be sort of measured in bucket trucks, and that meaning the fewer bucket trucks that an operator has to deploy means fewer people that have to be trained on that, and the lower costs associated with that. So we are seeing our members and other operators choosing architectures that are focused on reducing that outside plant and field tech investment. And again, that illustration of how the bucket truck, how our decisions ripple out into the different parts of the network, and using the bucket truck analogy, I think was really good. So reducing the number of bucket trucks is the goal.
Reducing truck rolls and having more of the fleet. Yeah. Okay, interesting. Well, let's jump right into kind of the talk about what next gen PON. I mean, of course, 10G PON is certainly taking off, but as we all know, it's not universal. But of course, there's a lot of talk about 25 gig PON, which Nokia has been pushing hard on. But certainly other folks are looking at what's beyond that 50 gig, and I know during my initial calls with everybody, we even talk about 100 gig. But if I could have each of you talk about the next phase and what where are we going next, and how can we reconcile all these things, and just kind of give me a little overview. If someone wants to start with that would be great.
Sure. I'll give it a shot if that's all right.
Sure.
So there definitely, this is an interesting time to be looking at the forward movement of PON, what technology to choose. As you mentioned, you've got 25GS PON sitting out there, and seeing some deployments. I think the choices being made on the 25 gig side are expedient. To be honest, a movement from 10 to 25 right now is a small premium as far as cost on the OLT side, and it's a very low risk given the ecosystem of vendors. Right, it's pretty limited at the moment, although growing. But like I said, it's a small premium, and our members, the ones that are testing it and doing trials with it, that's the overwhelming reason. It's a low risk for a fairly low premium, given that that equipment works with 10 gig as well. Deploying ONUs, they're not doing. That's just, it's too expensive at the ONU side, and of course that's where the money really is. There's concern over 50 gig is what we're hearing, and one of the concerns that on one side of this argument will be that 25GS PON is not a standard, and you could argue that might be true, but this industry, the entire industry, works on MSAs on a daily basis, right? So it's an MSA like the 25GS PON is just as valid as the SFF MSAs that we use for transceivers and whatnot. So with that said, so 50G PON, certainly has a following, especially in the telco space, especially in Asia, and spreading. It's got limited availability at the moment, but it certainly does take the path of the succession path of ITU PON in 4 times upgrades of bandwidth, that kind of thing. So moving from 10 to 50 makes a lot of sense if you're in that camp of the world. And then, like you said, we're already talking about 100 gig PON. Cable Labs has a coherent PON project underway today, working on a target of 100 gig. There are some that would mention that we don't need coherent optics to reach 100 gig, and I think that's a valid discussion. But in either case, you've already moved. Once you make that move from 25 into 50 or even 100, you've added a DSP and most likely a SOA into the hardware, which just has a fairly large step in cost. And so that's the reason we believe that coherent is the next step. And taking coherent from 100 to 200 is a fairly simple step, or maybe even to 400 gig. And so that's kind of where we're thinking as well. And I think that's also part of the decision point of a lot of operators. Like, could they adopt 25 now, skip 50 and hit 100 or 200 with, like I said, this fairly low risk investment, or do they want to go to 50? There's some valid concerns on both sides of that story.
Okay, I'll punt it back to Richard and Mike. Can I get your perspective on this?
Yeah, I like Kevin's thoughts on coherent. I look at PON as, again, going back to how do my customers make money? What problems are they trying to solve? With 25 gig, I'm under the impression that most of the customers are trying to solve, how do I give my customers a 10 gig circuit? And the way they do that is they put more bandwidth on the PON and they allocate maybe 2 or 3 10 gig circuits across the PON to customers. And that is certainly one way to obtain revenue from your commercial customers. It's not really relevant for residential. But you can also, there are multiple ways to solve that problem as well. You can just, 10 gig transceivers now are dirt cheap. And you can run a BiDi across your your outside plant and potentially solve the same problem. And if I'm going to ask the R&D group to focus a lot of time and energy on a technology, I wanted to solve my customers' problems. And none of the proposals, 25 gig or 50 gig problems, solve the distance problem. Whereas coherent PON solves that distance problem. It gives you more distance, gives you more effective use of a PON for one interface, and you fix the bandwidth problem as well. And if you fix the bandwidth problem, I mean, bandwidth solves almost all problems just about, right? So I'm a big fan of the coherent PON. I do believe they can get the price of the optics down to sufficiently low enough to be able to compete with non-coherent optics in a PON type implementation.
Mike, over to you. I know you get some thoughts on this.
Okay. Did you want me to go ahead and share?
Yeah, please.
Okay. All right. So yes, this area of the next generation PON technologies beyond that of 10 gig. So certainly, where we are with 10 gig, it's about 8.5 gigabits or so of throughput, regardless of the 10 gig technology that you're using. If you look at 25 gig PON, so the 25 GS PON MSA, it's a consortium. And so it's a little different than some of the other MSAs that have been around, because some of those MSAs were more on the, as Kevin talked about, the transceiver side, the lower level kind of optical areas. PON, as we know, has a MAC, has a PHY, and then has also a transmission convergence layer, a TC layer. And if you look at this, the 25 GS PON MSA, it combined two different standards organizations. It defined the IEEE and their work for 25 and 50 gig PON. And then it also combined the ITUT and its work on the TC layer. And that combination created this 25 GS MSA consortium. So it's a combination of essentially two different standards organizations. That's why the document's really light. It's about 20 pages or less. And the reason why the 25 GS PON MSA was formed is because 25 gig PON was rejected by both of those standards organizations, the IEEE as well as the ITUT. So what we're seeing here, and Kevin touched on it as well, there is low system and ASIC participation. Kevin talked about, the CPE and its price point is still going to be relatively high. And the reason for all of this is the low ASIC participation and likely low volumes. So if we look at 50 gig, there's two different versions, an IEEE version or an ITUT version. It seems like the ITUT PON standards have really, took hold in the marketplace. XGS outsells IEEE. We think, the ITUT from a standards perspective has won the PON the PON business. So ITUT PON defined 50 gig. So right now, ASIC vendors are making products, optics vendors are making products. They have a 50 by 25 solution or a 50 by 50 solution, all in the same ASIC. And it can enable PON network slicing, that's carving out some of the network. And it has a large ecosystem. One of the things that, and Kevin talked about this, about pricing. One of the things that drives PON pricing is the CPE. China has embraced 50 gig as their next generation PON technology. And then if we look at so that's why a lot of system vendors and ASIC vendors and even a lot of service providers worldwide are skipping that 25 gig. Now, the reason why, if we look back through history of PON technology, going from APON to BPON to GPON to XGS PON, and then 50 gig PON, they've all seen about a 4x increase in capacity. And that's important because the ecosystem, system vendors, ASIC vendors, and also the operators want to make sure that PON lasts for a long time and can cover a bunch of use cases. And here are some of those use cases that could be applicable to the next generation of PON technologies. So if you look at, business services as a segment, aggregation functions as a segment, and residential. So business services operators today are doing 10 gig services, but they're using point-to-point Ethernet. So they're carving out wavelengths for business customers. And in the future, if they're doing 10 gig services today, over the life of PON technology, they're likely going to move to 25 gig. So what can happen then is with PON technology, as long as you have the capacity, then you can start to enable some of these business services functions. The other thing about next generation PON, this is very important. PON was looked at as an access layer technologies for residential and small business. But with 50 gig PON technology, you can move and become an aggregation function. So some of those point-to-point Ethernet transport use cases for like Wi-Fi access points at venue locations, or mobile mid-haul or backhaul, or even transport to and from MDUs, cabinets, or even node locations. Those could all be served with a PON technology. And if you look at these, Wi-Fi 7 has 30 or 46 gig worth of capacity, perhaps at a venue. And you want to make sure that your access technology can have more capacity than that your transport technology can have more capacity than your access. So Wi-Fi 7, outpaces, the capacity of 10 gig or 25 gig. These in mid-haul and backhaul, these requirements came directly from the ORAN specifications. Working Group 9. They defined for service providers how much capacity that they needed to have to transport at these cell sites with these requirements. And if you look at these use cases here, there's really only one PON technology for next generation that can support all of these use cases. Okay, and so if we look at the timing of where we are, 25 gig, low ASIC participation, basically one or maybe 1.5 ASIC vendors participating, CPE side on each side. And if you look at, the future here, 50 gig is 18 months away. 100 gig by 100 gig or 200 gig by 200 gig, that's just now starting in the IT/UT to be defined. If you look at the trend line of all standards, we probably won't see a 100 gig by 100 gig or 200 gig by 200 gig PON system until the 2030s. That's standards based, like for example from IT/UT. So I hope that gives you a perspective, Sean, that you were looking for.
Oh, that's great. Richard or Kevin, do you want to add anything to the
No, I think a lot of Mike's points are valid. I'm still interested in the distance limitations or the distance issues associated with 25, 50 gig. Without coherence, coherent technology, you really don't get any further, and you may complicate the design by adding multiple frequencies. So while I agree with Mike that PON was never considered to be an aggregation technology, it was an access technology, not a transport, and I do believe that. And Harmonic's seen their customers when they're building cabinets or whatnot, they're putting relatively inexpensive white box switches with 400 gig interfaces in them now. So the ability to aggregate based upon electronic equipment in the field, the switches, is a lot easier now. And so, my idea, the concept of using PON to do my aggregation, it's possible. Do I want to do that? It remains to be seen, I think.
Yeah, I'll point out as well that first off, the 25 gig was not rejected by IEEE. In fact, Mike, you pointed out that 25 gig was adopted from IEEE over into 25 GS PON. So there is a 25 gig IEEE PON. In fact, there's a 50 gig PON over there.
Yeah, it's the 50. Yeah, because IEEE did basically 2 wavelengths to create 50. You basically, their standard is 50 gig MSA. So 802.3 CA 50 gig PON. That's the standard.
Yes. I guess the other thing I was going to point out, though, is even in the use cases you showed on the slide, there are certainly a couple there that you show that 50 gig can serve, but yet they, like the Wi-Fi 7 use case of up to 46 gig, that's beyond 50 gigs capabilities. And 50 gig today is not defined for 50 gig upstream. It's asymmetric. It's 50 by 25. Although the 50 gig is coming, right? It is coming.
All of that's standardized. All of it's in the standard. So it's 50 by 25 or 50 by 50. So if you look at the ASIC vendors, it's defined. I have a slide I can bring up if you'd like.
All right, well, that's fine. It's fine. I think we've got more important things to worry about.
Okay, all right. Yeah, it's solidified.
I love these kinds of conversations. This is great. I want to come back to something I think all three of you talked about at the beginning of our discussion is how to address brownfield environments. Of course, when we think of cable, they obviously have such an embedded base of HFC, and I guess the telcos have their embedded base of copper. But I would love each of you to kind of let's revisit that topic and the implications of considering the next generation of PON and getting into a brownfield environment. I'd like to explore that a little bit more with each of you.
I think there's multiple brownfield environments. If you're a cable operator, then you're going to a distributed access architecture for your DOCSIS implementation, in which case you have a 10 gig interface. You have 10 gig capacity within a couple kilometers of 50 to 500 homes. I mean, Mike's slide pointed out the numbers that a node provides. So if you can augment your node with a PON solution there, you can reach all of those customers on that node relatively easily. And from, again, the commercial perspective, what's important to me is not losing any customers. I want to lower my churn and increase my take rates and increase my service levels to customers to make more money. So if you can quickly deploy a PON service where your nodes are today, then that, I think, solves all those functions. You keep your customers, you offer new services, and you keep other people from building over your area as well. That's another thing that's very important nowadays, because you've got overbuilders coming out of the woodwork. And in the telco environment, EACAM does an awful lot with existing DSL vendors. So if you have a brownfield environment that's existing DSL and it's below the levels that are set by what's a broadband service, you can now get money to replace that. And again, by putting a remote OLT there, you can increase your service levels very quickly because you use the existing fiber that's already supporting that particular deployment.
Interesting. Mike and Kevin, you want to weigh in?
Yeah, go ahead, Kevin, if you like.
Yeah.
I'll sort of repeat some of what Richard said here, but certainly there's more than one brownfield environment, right? There's urban versus suburban, and those two call for different approaches. I think Richard's approach of building a PON into existing HFC enclosure that's already on the strand is certainly a valid point and one we would support. We're also seeing a lot of cable operators and a lot of telcos, honestly. I think it's more common for telcos, but a lot of cable operators are actually choosing to put cabinets out, right? Roadside cabinets to become cabinet farmers. And again, this rolls back to the bucket truck problem or the field tech problem of how do I reduce the cost of operations? How do I improve reliability? This workforce is trained for HFC, and when you put a PON device into the node, then you have a risk of folks up on those devices, up on a bucket truck, not understanding what they need to do because they haven't been trained. That's a solvable problem for sure. But the other problem is powering and access to, depending on how you do your splits, right? If you do splits, your split fields, your connector field near the OLT, or in the same box, then you've got field techs that may need to get in there. So you've got those types of things, and not having to climb up on a bucket truck to do that type of work is much more efficient than doing so, right? Climbing up the pole. So I think that's one of the big considerations, and this is especially the case when you start to talk about rural deployments.
Yeah. So, all right. So, yeah, just to touch back on. So, the 50 gig by 50 gig, it was approved in 2021 and 2023, February of 2023. The UW3 wavelength was added, and 50 gig upstream N1 optic was approved in February of 2023 with a dB budget of 29. And what's happening is there's future work going on for 50 gig upstream for C+ optics. So 50 by 50 is approved. We'll probably see 50 by 25 first, mainly on the optics side, and then we'll see 50 by 50 shortly after, maybe 2026 type timeframe. And with regards then to brownfield deployments, this is a very, very important topic for the operators. And because a lot of them, the majority of their homes passed, most certainly, comes from brownfield. So the new build, it's already a foregone conclusion that that's all going fiber to the home and PON technology. Many of the edge outs or extensions, they're going fiber to the home. So it's really in those brownfield markets where the operators are looking at what to do. And those operators that have been doing brownfield overbuild the longest, they started off doing sort of PON in the same manner they do HFC. They might take wherever that node is, and they might put a remote OLT next to that particular node or in that node if it was an option. But what they found is that by doing that, they just have far more numbers of OLTs to manage. And the whole theory, the whole reason of PON is in its name, passive optical networking. Now, because the cable distance between their facility and their subscribers are so long, longer than a typical telco CO, they had to go with some actives in the outside plant. But what the operators have decided, those that have been doing brownfield overbuilds the longest, they have decided we're going to try to re-architect the fiber to the home network for the next generation. So we're not going to deploy PON the same way we did HFC. We're going to have as few network elements as possible. And that's where remote OLTs and cabinets come in.
So I just make one comment. Yeah. I agree with a lot of what Mike's saying, but when you come back to how do I make money in this business, you need to stop churn. And if the way I stop churn is by putting PON out to my customers, and part of that process is to revamp my entire feeder network, my entire trunk cable, because I want passive all the way out to the nodes. And by the way, in an environment where I already have power everywhere, I want a PON device out there now so I can stop churn. And if you want to, and you want to stop the churn now, and later on, if you want to go make all that passive, I agree that passive is ideal, but also unless you have 100 gig PON with coherent, I'm not sure you can do that without putting those devices in the field. So it's a balance, right?
Yeah. Yeah. What I would say is that if you look at what's happened in our industry, in the late 90s and early 2000s, we did a rebuild. And a rebuild is where, you overlay fiber to your serving areas, and then you upgrade and update and remove portions of the plant and upgrade that with new cable. So what happened during that last rebuild, now since then we've been doing upgrades. Those are just electronic changes, but a rebuild is different. So what happened in the late 90s and early 2000s is we put fiber at these node locations. Those node locations could be 500, 1,000, or 2,000, and ran that fiber all the way back to the facility. What we did between the late 90s and the early 2000s to today is we've been doing node splits. We've been taking the fibers from those serving areas and extending them to these different neighborhoods. Why? Because DOCSIS needed to have the capacity, okay, to do that. What the operators have found that have been doing brownfield the longest is, if they go to those original node locations where they have 6 or 12 fibers, they already have fibers running to all of these node split locations. That means that a node could be deployed at maybe 1,000 home pass location or 2,000 home pass location, and then have that entire serving area passive for PON. And PON technology can go further than DOCSIS in terms of from an RPD to, you know, a CPE. So that's why they're looking at using PON technology and not architecting it like they would HFC, architecting it as they would for a distributed fiber to the home architecture.
Yeah, and I think we just said the same thing. You're essentially passive from the node out. So I think we're agreeing. Your agreement.
Well, yeah, it's just basically how many. I mean, so you want to have fewer active points. And that's why aggregation, like if you look at a node location, it could be 8. If you look at a cabinet location, it could be even several thousand subscribers could be served out of there by a cabinet-based OLT. So if you look at some of I think the typical homes passed per node these days could be in the 300 range or 200 range or something like that with all the node splits that have happened over the last 20 years. What we're saying is go back to the original node location where you have high home pass density and put your PON electronic there.
Great. So as we come up near the hour, I'm gonna grab a question that just came in, and then we'll kind of keep going a little bit longer. But this question is: with all the hype around symmetric services, why do the SDOs even create asymmetric options like 50G down and 25G up? Is it because symmetry isn't really necessary, even though we hear all the hype about it? That's an interesting question. Yeah. Anybody wants to weigh in?
It was really for price point. So, there is a different technology that's needed to go from 25 to 50. And so that's really one of the reasons why they've done that. The standards organizations want to have flexibility in terms of, having price points for different applications. And but the operator has the choice. If they want to wait for a 50 or a symmetrical solution, they can, or if they want to deploy an asymmetric solution, they can.
Kevin, want to weigh in? Or, no?
Yeah. It's kind of a tough one, right? I mean, it depends on the reality is that the average user, residential user, is not using symmetric bandwidth. They're not even using 10 gig. I mean, we're deploying 10 gig. The 10 gig is really about hitting billboard rates. What we're advertising. What our advertisers. I mean, you look at Ziply Fiber. I mean, they're advertising a 50 gig fiber optic service, right? That's ridiculous. Right. When the average user is barely hitting 20 megabits at peaks, right. and arguably data would show they're not even hitting that. I think the symmetric services are important for things that Mike pointed out, right? So if you're going to do any sort of backhaul, mobile type backhaul, or even commercial services, right? You need symmetric service. Even there, a lot of the time, that's still going to be a sales thing, right? I'm being asked to provide a symmetric service, and therefore I'm going to provide that, even though the use profile isn't supporting that. So yeah, I think symmetric services are important. I think 50 by 50. I don't know that we're hitting that today, but it certainly is a necessity in the market, and that's what we're doing in the 100 gig PON as well, 100 gig C PON to support that. So,
okay, Richard, any thoughts? Okay.
No, I mean, I think a lot of it's time to market, right? So can I get us product out? I mean, look at Nokia's progress in 25 gig. They use it to their advantage to push their prominence in PON, and they've done a great job at it. And then, by the way, I don't want to come across as Harmonic's not supportive of 25 gig. Every product we ship in the last roughly 6 months, I can stick a 25 gig PON in there. So I'm not at all against it. I just think long term, I mean, Kevin hit that ugly truth that and I've been looked at in a dirty way. And these panels, I shouldn't bring up the fact that no one's using any bandwidth, right? But the reality is they're not. And I would also encourage people to look at, and Mike's products and my products both have switches integrated into their overall system. There's nothing stopping you from putting a point-to-point fiber, because you're deploying fiber to the customers anyway, and you're not just going to deploy one fiber. So you can either use a wavelength or a fiber to go to a customer for a commercial customer. And Kevin's very aware of this. When I was with one of my employers, we tried to sell commercial services through PON, and it was very difficult because the way that company did their design for the network services, even if it was only 100 megabit or whatnot, it was too difficult for the salespeople to comprehend selling it over PON, so they did point-to-point. So you have to take in both sides, not just the technology, but how the salespeople and service people deliver that service.
Great. So we're running right up against the hour, so I'm just going to ask if each of you could just share some final thoughts, and then we'll wrap up because we got a really tight schedule today. If anybody wants to jump in, just give me some final thoughts. We could probably have another webinar on this topic, addressing a number of other issues that all of you have addressed. But if everybody could just give me some quick final thoughts, we'll wrap up here.
Why don't you start, Kevin? You're the least biased of the three of us.
Oh boy.
But I think I'm going to put a plug in for what I'm really passionate about here, and that is the fact that we're moving this stuff we're moving broadband into rural places to people who don't have it. It doesn't matter. The architecture that is chosen is going to be dependent on the specific needs of the specific operator, and even down to the area that they're going into. And that's the story we're hearing is. They're adjusting architecture based on the specific use case, trying to stay within a specific or within a general theme, but adjusting based on that. But the reality is what we're doing on a day-to-day basis is impacting people in their personal life, right? So we're delivering a product that brings enriched lives or enriches people's lives, and we need to remember that no matter what we do.
Go ahead, Rich.
Go ahead, Mike.
I would second that. I speak of it in terms of commercial viability and making a profit. But Kevin's right. Essentially, we're selling services to customers so they can access data and enrich their life. But you also have to take into consideration that things like billboard rates are important, right? So the way you make money in this business is to be able to offer a service that's sexy, oftentimes. With the current financial issues we have today, maybe people are looking a little more closely at, I don't want a gig service. And I've had one of my customers tell me they have a halo effect. If they offer a gig service, nobody might take it, but they're going to take their 20 megabit service and say, well, I can get a 40 meg service now, and they can upcharge them, move them. It's all about making money, right? And then lastly, the high density areas, they're gone, guys. They're gone. You've already got them. You've won them. They're gone. Your new deployments will be very low density deployments, and you need to have some optionality in the equipment that you're deploying. And, Mike put up some nice slides about disaggregation and whatnot, and I think that's important because you're going to need to use different technologies when you get closer and closer to the customers. It's not just a remote OLT, it might be a micro OLT, right? Because you're only serving 7 houses in a 10-mile stretch, right? You just don't know. And you're getting paid to do that. So you have to have a solution that you can not manipulate, but you can make work for you in the situation that you're using it for.
And finally, Mike, to you.
Yeah, so a couple of points that we talked about. I think there's about 4 fundamental areas here. So we talked about ways that the cable industry can accelerate the adoption of IT/UT-based PON. They have options. If they want to start with their DOCSIS back office systems, they can. If they want to leverage a part of their DOCSIS back office system and then use a different provisioning and network management system, they can. Those solutions are available today. And then if they want to eventually have an architecture that migrates over to the broadband forum type interfaces with an SDN type controller and orchestration layers, they can. But all of the underlying equipment, the OLTs and the ONTs, can be part of that entire transition without changing it.
Great.
The other thing is in the area of the OLT architecture and traffic management. I think the biggest question that we have as an industry, do we want to have 10 gig PON, 25 gig PON, or 50 gig PON going through an x86 server somewhere in the network? Or do we want to have that going through a purpose-built ASIC as close to the customer as possible? And north of that is just doing packet switching. And then the third topic we talked about was deployment. So do we want to deploy PON the same way we do HFC? If we do that, we'll have between 4 and 16 times more active equipment in the network. Aggregation of PON technology where and when it makes sense can reduce the number of actives that you have in the field. And the fourth thing was the next generation PON technologies. Do you start with a small hop of 25 gig, or do you wait about 18 months and have 50 by 50 gig solution available to you that can meet all of those use cases?
Great.
And one other thing, 50 gig PON technology can enable PON slicing. You can carve up portions of that network for different applications, but not frame it up. Unused capacity can be shared by all. So those are some key points I'd like to leave the audience with. Thank you.
Great. Well, thank you, Mike.
Thank you all, panelists. Well, appreciate it.
Yeah, no, you all did a great job. Thanks very much for everybody's time. Well, I'm afraid we've run out of time for those questions we didn't have time to answer. We'll be getting back to you via email. So this concludes today's presentation. I'd like to thank again our great panel of presenters today for participating in today's event, Richard, Mike, and Kevin. Once again, please do fill out the survey that will pop up once this session concludes. We appreciate your time filling this quick survey out, as will help us provide guidance for future content we continue to provide. Just a reminder that a certificate of attendance will be sent to you separately for attending this entire session. To receive SCTE recertification unit, you must fill out the SCTE recertification form and submit to SCTE directly. Next up, don't miss our next session, which is Understanding BABA, what network constructors and operators need to know. This is going to be moderated by my colleague, Patrick McLaughlin, and that's coming up at 10 o'clock. So you could just exit out of this event, going back into the agenda and clicking on the View Session button within the agenda to attend that if you like. Again, thanks for attending us on this BTR Summit, and let's continue with this packed day of learning. And once again, thanks to Mike, Richard, and Kevin for some really great insights today. Thank you very much. Thank you. Have a great day.
Thanks, guys.
Thank you. Yep.